Number 39, summation that's n goes from 1 to infinity, n factorial in parentheses squared over 2n in parentheses factorial. Okay, the big clue here is factorials. So which test is good for getting rid of factorials? The ratio test. So we just got to be careful with our parentheses here and with our algebra, right? Limit as n goes to infinity, a sub n plus 1 divided by a sub n. So a sub n plus 1, replace each n with n plus 1. So this is where I'm saying be careful with the parentheses. Okay? And divide by a sub n is the same thing as multiply by the reciprocal of this guy. Okay? So let me go through the algebra. This m plus 1 factorial in parentheses squared, I wrote it as the product of 2. Okay? And then this over here, I distribute the 2, so it becomes 2n plus 2 factorial. And then this n factorial, I wrote it as n factorial times n factorial. This 2n factorial remains over here, okay? Now let's start canceling some stuff if possible. n plus 1 factorial is the same thing as n plus 1 times n factorial, yeah? So both of these, you can write it as that, and those n factorials will cancel with these two on the bottom. And then 2n plus 2 in parentheses factorial is 2n plus 2 times 2n plus 1 times 2n factorial. So you're left with 2n plus 2, 2n plus 1, because the 2n factorial from that will cancel with this one on top. Okay? So now, if we take the limit, what's the way to do this? You can expand everything out if you want. You don't need to. But you really just care about the biggest degree term. The biggest degree on top is 1n squared. On the bottom is 4n squared. Okay, degrees are the same. Take the ratio of the leading coefficients. That's 1/4. This is less than 1. So what does the ratio test say? This series absolutely converges, which means it converges.